Have you ever wondered if the world around you is actually there when you're not looking? Not in a poetic sense, but literally. What if the objects you see, the sounds you hear, even your own body, only become real when observed? That's not a metaphor. That's the core paradox haunting physics for over a century. The deeper we look into quantum mechanics, the less solid reality becomes. Particles behave like possibilities until we measure them. Space and time twist depending on who's watching. And experiments, real, verified, repeatable, are forcing scientists to face an unbearable question. Is the universe built from reality or from observation? Think about this. You drop your phone on the floor. It bounces, you pick it up, it's real. You feel its weight, see its screen. But quantum mechanics says, before your observation, before any interaction, that phone might not have had a single, definite position. It wasn't anywhere. It was a wave of probabilities. This isn't fantasy. This is physics. The double-slit experiment, quantum entanglement, the delayed choice paradox, all point to one chilling idea. Reality might not exist in the way we think until consciousness, or at least measurement, collapses the possibilities into something definite. And if that's true, then the universe doesn't exist out there waiting for us to see it. It exists because we see it. But before we jump to that conclusion, we have to ask, what exactly is this realness we think we understand? To understand when reality stops being real, we have to go straight into the heart of quantum mechanics, where real itself starts to dissolve. Let's start simple. Imagine you're firing tiny particles, electrons, at a wall with two slits. Common sense says each electron should go through one slit or the other, just like pebbles through holes. But when no one looks, something impossible happens. The electrons act like waves, interfering with themselves and creating a pattern on the wall that only waves can make. It's as if each electron passes through both slits at once. Now here's the nightmare. When scientists place a detector to see which slit the electron actually went through, the interference disappears. The pattern changes. The electron suddenly behaves like a particle again, going through just one slit. The mere act of measurement changes the outcome. Observation reshapes reality. This is the essence of quantum weirdness. It's not that our tools disturb the particle. It's that the universe itself doesn't decide what's real until the measurement happens. Before observation, every particle exists in a superposition, a cloud of probabilities, containing all possible states at once. Physicist John Wheeler once took it further with the delayed choice experiment. He showed that even if we decide after the particle has passed the slits whether to observe it, the past seems to know what we'll do. The measurement in the present decides the behavior of the particle in the past. Reality doesn't just wait for us, it responds to us, even backward in time. Einstein called this spooky, and he wasn't wrong. He believed reality existed independent of observation, but experiments kept proving otherwise. Quantum theory keeps whispering the same thing. The world is not made of things, but of potentialities. So, when does reality stop being real? Maybe it's the moment before we observe it, that threshold where the possible becomes the actual. A world that exists in pure probability, without any defined shape, until awareness gives it form. It's unsettling because it suggests there's no objective universe out there. Everything we touch, measure, and call real might be emerging from an invisible field of maybes, one that solidifies only when consciousness, or at least observation, locks onto it. But if reality depends on observation, what happens when no one's watching? Common sense tells us that reality is continuous, that a rock stays a rock whether or not we're there to see it, that your room doesn't vanish when you close the door, that the universe rolls on, indifferent to your gaze. But quantum mechanics quietly laughs at that certainty. In the quantum realm, things are not things until they're observed. Between observation and unobserved existence lies a realm our intuition can't grasp, a world of probabilities, potentialities, and mathematical ghosts. This is not poetry. It's what the equations literally say. Think about that cup on your table. In the classical world, it has a definite position, mass, and color, independent of you. But zoom in far enough, beyond atoms, beyond electrons, and you reach a place where the concept of cupness dissolves. At that level, there is no object until interactions define it. The cup is a web of relationships, not a solid thing. Physicist Carlo Rovelli calls this the relational interpretation, that reality is not made of things, but of relations between things. An electron doesn't have a position unless something else, another particle, a detector, or maybe consciousness, asks for it. Reality is a dialogue, not a monologue. This demolishes our sense of an independent universe. What we call reality might be the emergent shadow of interactions, a kind of cosmic language spoken between particles and observers. Without those interactions, there's only uncertainty. And that leads to something even stranger. If the universe only becomes real through observation, then it's possible that the observer, you, is part of what creates the universe's reality. You're not a spectator inside the cosmos. You're a participant in its unfolding. It's like a cosmic feedback loop. The observer gives reality its shape, and reality in turn gives the observer meaning. The boundary between out there and in here starts to blur. But that blurring creates a paradox we can't easily escape. Because if the act of observing is what brings the world into existence, then who or what observed the universe before humans, before consciousness, before life itself? Was the universe waiting, silent and undefined, for eyes to open and see it for the first time? Or is there something deeper, some form of cosmic awareness embedded in the structure of reality itself? Whatever the answer, it suggests that real might not mean what we think it does, and that we may be standing inside an illusion woven by the act of looking. And yet, if this illusion is shared by all of us, how do we even begin to tell where the real world ends and the observed one begins? To say reality depends on observation sounds mystical, but what if it's just experimentally true? Let's climb the ladder of evidence. 4 levels that show how physicists, one experiment at a time, watched reality slip through their fingers. Step 1. The double-slit experiment. We started here for a reason. This classic test showed that light and matter can behave like both particles and waves, depending entirely on whether we observe them. The interference pattern that appears when we don't measure and disappears when we do isn't a trick of instruments. It's a measurable physical difference, confirming that observation changes outcomes. The key isn't human eyes, but information, whether the system knows it's being watched. Step 2. The quantum eraser. Physicists pushed further. What if we erase the information after the fact, delete the record of which path the particle took? Incredibly, the interference pattern returns. It's as if reality rewrites itself based on what could be known, even after the event. This implies that reality doesn't just depend on observation, but on potential knowledge. If the information exists, reality chooses one form. If it doesn't, another. Reality seems aware of information itself. Step 3. Delayed choice experiments. John Wheeler's thought experiment, later tested with photons, added another twist. What if the decision to observe happens after the particle has already traveled? The results still conform. It's as though the universe retroactively decides what happened. Cause and effect begin to tangle. The future seems to sculpt the past. Reality no longer unfolds like a film reel. It behaves more like an editable file. Step 4. Macroscopic superpositions and quantum computing. Until recently, these effects lived in the microscopic realm, but now, researchers have created macroscopic quantum states, superconducting circuits and molecules visible to the naked eye, existing in superposition. Quantum computers rely on this. Qubits represent 0 and 1 simultaneously until measured. The same principle that makes your phone's processor binary allows a quantum chip to exist in infinite potential. If that's not a technological validation of reality as probability, what is? Across all these steps, one theme emerges. The world doesn't seem to decide on a single version of itself until interaction forces it to. The fabric of reality acts less like stone and more like memory, dynamic, informational, and responsive. Yet even as the data mounts, an ancient question returns in a modern form. If reality depends on interaction, who or what is doing the observing when no one's around? Does reality itself observe? At this point, the data forces a question that science alone can't comfortably answer. If reality depends on observation, then what exactly is doing the observing? Is it the measuring device, the human mind, consciousness itself, or something deeper, an intrinsic property of the universe that allows awareness to emerge as part of its fabric? For centuries, physics and philosophy lived on opposite ends of human curiosity. Physics dealt with the measurable, philosophy with meaning, but quantum mechanics cracked that wall. The observer became inseparable from the observed. Suddenly, the very act of measurement, something we used to think of as passive, began to look creative, even participatory. One interpretation, known as the Copenhagen interpretation, suggests that observation collapses the wave function, that possibilities become real through measurement. But other interpretations go further. Wigner's hypothesis, for instance, proposed that consciousness is the key ingredient. The universe doesn't collapse until a conscious observer perceives it. It's a daring idea that awareness might not be an accidental byproduct of physics, but its very foundation. Critics, of course, recoil. They argue that consciousness cannot be a physical mechanism, that the equations don't require mind to explain them. Decoherence theory, for example, suggests that quantum probabilities collapse when they interact with the environment, when atoms, photons, and air molecules exchange information. In that view, reality becomes real through entanglement with its surroundings, not because someone is watching. Yet even this explanation carries a strange implication. Reality doesn't exist as definite things. It exists as relationships of information. Consciousness might not create reality, but it still participates in it. We are part of that web of relational definition. We are the universe reflecting on itself. Philosophically, this shifts everything. If reality requires interaction, then objectivity, the idea of a world that exists completely independently of us, is an illusion. It's not that everything is in your head, it's that the head and the cosmos are two sides of one continuous process. The most radical thinkers, like physicist John Wheeler, proposed a concept called the participatory universe. He suggested the cosmos is not a machine running on its own, but an evolving feedback loop where observers bring the universe into being through acts of measurement, what he called observer participancy. And if Wheeler was right, then we might not be living in the universe at all. We might be helping to build it, moment by moment, observation by observation. But if the act of observing helps shape reality, could the collective observation of billions of minds actually steer what the universe becomes next? If reality is participatory, then the future of science isn't just about observing the universe. It's about co-creating it. This idea once sounded like mysticism, but today it's beginning to infiltrate quantum technology, neuroscience, and even artificial intelligence. Let's start with quantum computing. In these machines, the boundary between potential and actual isn't abstract. It's hardware. A qubit exists in multiple states until measurement collapses it into one. In other words, each calculation is a dialogue between probability and observation. Engineers have begun to manipulate the conditions under which collapse happens, effectively deciding how and when reality chooses. It's a controlled interaction with uncertainty itself. Now imagine that on a universal scale. If consciousness, or even measurement, can influence quantum states, could advanced civilizations someday learn to tune reality, just like we tune frequency? Could the next step of science be less about discovering reality and more about designing it? Physicists are already testing the edges of this question. Quantum simulation experiments now mimic entire universes of interacting particles inside controlled environments. Each tweak creates new possible laws of physics. It's as if we're learning to sculpt the code that underlies the cosmos. Then comes AI, artificial observers. As machines become increasingly capable of making autonomous measurements and decisions, they too participate in defining quantum events. In a strange twist, non-human observers are joining the cosmic dialogue. The line between human awareness and universal observation starts to blur even further. Philosophers like Donald Hoffman have proposed that reality might be a kind of user interface, an evolutionary tool that hides the complex quantum substrate beneath. Just as icons on a screen simplify code, what we perceive as objects might just be symbols for deeper quantum processes. If we learn to hack that interface, not metaphorically but literally, we could reshape our perception, our consciousness, even the fundamental rules that govern what's possible. But here's the real horizon. When experiments begin merging quantum physics with neuroscience, measuring how conscious attention interacts with probabilistic systems, the question of reality's limit becomes more than theoretical. It becomes personal. If consciousness plays any role at all in the emergence of the real, then the future of science won't just describe the universe. It will depend on who's looking and how deeply they dare to see. And somewhere beyond that boundary lies the possibility that reality itself might evolve in response to the observers who learn to understand it. But if that's true, if our collective perception actually shapes what's possible, then what happens when humanity agrees on a single version of reality? Could we accidentally trap ourselves inside it? Let's pull this down from the cosmic to the intimate, from quantum fields to the small, quiet moment where you're sitting right now, listening, thinking. Because if everything we've discussed is true, if observation defines reality, then your attention isn't just awareness, it's creation. Think about the choices you make each day. What to notice, what to ignore, what stories you tell yourself about who you are. Each one is an observation, a collapse of possibilities into one version of your life. Maybe that's what consciousness is doing all the time, filtering infinity into something coherent enough to live inside. When you look at a tree or hear someone's voice or remember a moment from your past, you're not just receiving information, you're participating in shaping it. The colors, the meanings, the emotions, they exist because of the observer's lens. Reality and perception are locked in a dance, each giving form to the other. This changes how we think about responsibility too. Because if every act of observation helps define the world, then indifference isn't neutral. It's participation through absence. What you don't look at, what you refuse to engage with, also shapes the structure of what remains real. The ignored, the unseen, the overlooked, they fade from the shared version of reality we call truth. Now imagine this scaled up. Millions of minds focusing on conflict, fear, division. Those are collective observations, collapsing probabilities into darker worlds. But millions focusing on creativity, empathy, exploration. That's a different kind of collapse entirely. If the participatory universe idea holds even a fragment of truth, then attention is power in its most literal form. That means you are not a passive passenger on a pre-written path. You are a participant in the universe's ongoing construction. The boundary between physics and life dissolves here. The observer effect is not just a lab result, it's a mirror. And maybe this is what ancient philosophies were hinting at long before quantum equations existed, that reality is relational, consciousness is causal, and awareness is a form of creation. Science may be rediscovering what mystics have been describing for centuries, that the world you experience is entangled with the way you choose to see it. But there's still one last question, the one that cuts deepest. If reality becomes real only when we observe it, what happens to us when the universe stops observing back? Maybe reality doesn't stop being real. It simply stops being ours when we stop observing it. The quantum world doesn't vanish. It just returns to potential, waiting for the next conscious glance to call it back into form. So picture this. You're standing in the middle of a quiet street at night. No one else is around. The streetlights hum softly. The world feels solid, unmoving, permanent. But somewhere beneath that stillness, countless particles are dancing in uncertainty, each one flickering between existence and probability. You, standing there, are the momentary anchor, the observer holding that fragment of the universe in place. When you blink, the world doesn't disappear. But according to quantum law, it may very well shift. Not dramatically, not perceptibly, but subtly, reshaping around the act of being noticed. In that sense, we are all sculptors of the real, tracing invisible lines through the possible. So maybe the question isn't, at what point does reality stop being real? Maybe it's, at what point do we stop participating in its creation? Because the act of wondering, questioning, observing, that is what keeps the universe alive in our perception. Without it, everything reverts to silence. Reality might not be a fixed structure at all. It might be a living conversation between consciousness and cosmos, one that only continues as long as we keep asking the question. So tell me, do you believe this quantum idea changes everything? Or is it just science fiction? Tell me below. Your view might change someone's mind.